So I'm going to give several antiderivative formulas that are useful when trying to solve antiderivative problems. Okay? The antiderivative of a constant, let's call it k with respect to x, is that constant times the variable x plus the constant of integration. Okay? The antiderivative of the cosine of x is the sine of x plus the constant of integration. The antiderivative of the sine of x is minus the cosine of x plus the constant of integration. All of these are antiderivatives with respect to x. Let me say that. What about the antiderivative of a power? Let's say x to some exponent n. Okay, that's equal to x to the n plus 1 all over n plus 1 plus the constant of integration. And this is good as long as n does not equal minus 1. In that situation, you'll have a division by 0 error. All right, so but all other numbers are fine. Okay, and then let me give you two more. The antiderivative of a constant, let's call the constant k, times a function, let's call it the function f of x. So k f of x, and again with respect to x, you can simply calculate the antiderivative without the constant as long as you multiply your answer by k. And I'll give you an example of that in a second. And then lastly, the antiderivative of a sum of functions, let's call them f of x and g of x. The antiderivative of the sum of functions is equal to the sum of the antiderivatives. Okay, so I'm going to do two examples and then I'll have you do two examples. The antiderivative of 54 with respect to x is equal to 54x plus the constant of integration. I used the first formula to solve that one. The antiderivative of x to the 10 with respect to x is x to the 11 divided by 11 plus the constant of integration. I used the fourth formula to do that one. What about the antiderivative of 7 times x to the 10? How is that going to change things? Well, according to the fifth formula, I simply multiply the old answer by 7. All right? I invite you to take the derivatives of the right sides of those red equations and convince yourself that they give you the original functions on the right side, on the left side. Okay? And let me do an example of the last, that uses the last formula. What about the antiderivative of 54 plus 7x to the 10 with respect to x? I hope you see that I'm combining the first and third red antiderivative problem. Okay? So in order to answer this fourth red antiderivative problem, I'm simply going to combine the old two answers. So 54x plus 7x to the 11 divided by 11 plus the constant of integration. All right? Let me finish by asking you to do a few. All right? Can you tell me what is the antiderivative of the sine of x plus the cosine of x? Can you also tell me what is the antiderivative of minus 12 times x to the 5 with respect to x. Pause the video and try to do those now, please. All right, I'll go ahead and do these. So the first one, the antiderivative of sine. Well, first of all, I'm allowed to simply focus on each function separately and then add my answers together. So the sine of x, the antiderivative of the sine of x with respect to x is minus cosine. The antiderivative of the cosine of x with respect to x is sine, plus the constant of integration. And so maybe you like to put the sine first in this case, so you don't have a negative to start things out. All right, so that's maybe a nice way to package that answer. And then the last one, minus 12 times x to the 6 over 6. We can simplify that to minus 2. Oh, and by the way, I forgot the constant of integration. So let me put that in there. So that's equal to minus 2x to the 6 plus the constant of integration.